fast, where truth moves faster than a Holstein calf. No waiting on some pretty page. We're charting new ground in the digital age. From genomic codes to row-wide facts, we cut through the noise, no holding back. Not your daddy's dairy news tonight. We're sparking debates with every insight. The ring's not where the real fight's at. It's in the data, in the channel chat. From pasture to processor to your morning cup, we're raising the stakes. Try and get ahead of herd. Yeah! Where the future's more than just a word. Ahead of herd. Come on! The Bullvine's calling, let your voice be heard.
Welcome back to the Deep Dive, where we cut through dairy industry noise to get you the insights that actually matter for your operation. Today, we are wrestling with a topic that, on paper, promises guaranteed dollars, yet still sits squarely in the maybe later category for too many farms, dairy barn lighting.
And, this is a deep dive centered around a feature piece focusing on a potential 8% production boost from simple LED lighting. Sounds almost too good to be true, right? But the biggest surprise isn't the science. It's the sheer conflict between the academic data and the farm reality. We have 20 years of rock-solid science confirmed by people like Dr. Jeffrey Dahl and others since the early 2000s, showing a dramatic, huge return on investment, yet widespread adoption on farms. It just hasn't materialized.
That is the core conflict we're tackling today. We're looking at a solution that has been definitively proven to work, but is somehow, being overlooked. Our mission is to determine if simple, high-quality LED lighting is truly the next low-cost efficiency driver that farmers are missing out on. Or if it's just another expensive gimmick the industry has successfully managed to overcomplicate with complex control systems and maybe unnecessary spectral tuning features.
Yeah, it's time for the no BS answer for the farmer making those capital investment decisions. And, we have to start with the context here because the technology lag in this specific area is massive. It's kind of staggering, actually. When you look at the research pipeline for things like, say, genomics or robotics, it moves pretty quickly. But lighting, walk into most dairy barns today and you are still looking at ancient fixtures, metal halide, high-pressure sodium, maybe even old fluorescent tubes that, frankly, belong in a museum. This represents a monumental disconnect.
And the stakes couldn't be clearer. We're talking about an average 8% increase in daily production. That's not trivial. We ran the conservative numbers on what that actually means for our listeners.
Yes, and these numbers should really snap people to attention. An 8% bump translates to about, 2.5 pounds per day per cow against standard production. Now, let's take a modest 100-cow herd averaging, say, 75 pounds per day. If we assume that 8% increase, that's 6 additional pounds per day per cow overall, which, at current prices, translates to potentially over $34,000 in additional annual revenue.
$34,000.
Yeah, and that's against a relatively small investment in hardware, potentially.
That's pure opportunity cost being lost every single year the lights aren't addressed. And here's the provocative insight we kind of derive from looking across all the sources. Simple $600 LED systems can, and often do, match the performance of complex integrated systems costing $6,000, $15,000, or heck, even more.
It suggests that the dairy farmer might actually be better off sticking with the absolute proven basics, good light, for long enough, rather than chasing optimization targets that might not even really exist due to the messy reality of bovine biology. We suspect the industry has significantly overcomplicated the solution to justify an enormous price tag when the core problem, like you said, is just a profound lack of light in a lot of these old barns.
All right, let's unpack this and get specific on the data, because understanding the mechanism is key to trusting the investment, right? The science is pretty undeniable. The proven protocol, replicated for 2 decades now, is 16 to 18 hours of continuous light exposure.
And that light needs to be at a target intensity of 100 to 200 lux at cow eye level. To put that in perspective for folks listening, 100 lux is roughly the legal minimum for a well-lit walkway, and 200 lux is what you'd probably experience in a decent well-lit office environment. It's consistent, defined light, not just, stray barn light leaking in.
It's all about the hormonal cascade. That's the key. When the cow's system receives that extended light, it suppresses the nighttime hormone, melatonin. Melatonin is produced in the pineal gland, and light exposure basically flips that switch off.
Exactly. And less melatonin means the body enters a more productive phase. This is where we see 2 critical hormonal responses. First, a significant 15 to 30% increase in IGF-1, that's insulin-like growth factor 1. What's important here is how IGF-1 works. It doesn't just improve efficiency vaguely, it actively redirects energy.
That's right. The presence of IGF-1 helps prioritize nutrient partitioning towards the mammary gland. So those valuable calories the cow eats are being more efficiently shuttled away from, say, maintenance or body fat, and directly towards milk production. Your feed is literally getting a huge boost in effectiveness.
And the second hormonal factor is the bump in prolactin, which increases by, get this, 25 to 40% when melatonin is suppressed. Prolactin directly stimulates the epithelial cells within the mammary tissue, driving milk synthesis. So it's kind of a double whammy.
A double whammy.
Better feed utilization from the IGF-1 and increased biological factory stimulus from the prolactin.
Wait, did you catch that part about prolactin increasing 25 to 40%?
Yeah.
When you put it like that, it changes the conversation entirely. It means that if I haven't fixed my lighting, I'm not just losing a percentage point of volume, I'm actively suppressing the hormone responsible for milk synthesis by a really significant fraction. I'm literally leaving thousands of dollars in improved efficiency and increased volume in the bulk tank every single month because I haven't bought a timer and a few bulbs.
Exactly. That number alone should be the driver for every single farm decision. But here's where the management complexity comes in, and maybe why some farms hesitate. The dry cow paradox.
Ah, yes, the dry cows. The research is really clear on this. Dry cows require the complete opposite protocol to set up their next lactation successfully. They need the short day protocol.
Absolutely. Dry cows actually need 8 hours of light, followed by 16 hours of complete darkness. The purpose of this short day manipulation is to allow prolactin levels to drop significantly during the dry period. When prolactin drops, the receptors for it become more sensitive. So when the cow freshens and she moves back into the long day environment, those receptors are super primed, maximizing the response in the next lactation cycle. You are literally setting the stage for increased production a year in advance.
Okay, so if you're a farmer listening, you now have two completely contradictory lighting protocols you need to manage on the same facility. Lactating cows needing 16 to 18 hours and dry cows needing only 8 hours.
That duality is the theoretical hurdle, right? But let's be honest, in the real world, the dry cow protocol is often the one that gets shoved aside first, and that's a massive missed opportunity for priming their system. And it's particularly challenging for smaller farms. If you're running, say, less than 200 head, you often don't have completely separate, isolated housing for your dry cow group where you can achieve complete light separation. It's just not practical.
In that scenario, you're forced to make a tough capital decision. Prioritize maximizing the current milk check from the lactating cows, or invest in potentially expensive structural solutions to maximize the next lactation from the dry cows. Given cash flow pressures, most farmers understandably choose the immediate milk production boost. It makes sense financially in the short term.
So let's talk about why, despite this rock-solid science and those huge financial incentives, universal adoption hasn't happened. It's because I think the industry is trying to sell a perfect solution to an imperfect biological problem.
Yeah, we have to challenge the conventional wisdom that we should always chase the next tiny efficiency gain. The problem is the discrepancy between the neat, tidy research trials and the messy, dirty reality of the barn.
Think about where the research gets its most jaw-dropping results. So they show responses up to 15%, which is huge. But when you drill into those papers, you realize those massive improvements are generally seen on farms starting from a truly poor baseline. We're talking about old barns that had maybe 30 or 40 lux, perhaps from ancient dyeing fixtures. When you suddenly introduce 150 lux there, of course you see a massive jump. The bar was practically on the floor, so any light works wonders.
That's the trap, isn't it? If a farm is already using decent lighting, say modern T8 fluorescent tubes that still manage to provide maybe 100 lux, the additional improvement you gain from upgrading to high-end LEDs might be minimal, maybe only 2% instead of 8%. And suddenly the cost-benefit equation flips completely.
And this brings up the biggest confounding variable in real-world dairy farming. How often does a farmer upgrade just their lighting?
Almost never.
Right, never. Lighting upgrades almost always coincide with a full renovation. Fixing ventilation, upgrading cow comfort, installing a new feed system, maybe adding cooling misters. Everything changes at once.
So you see an increase in production? Great. But you can't really tell if it was the better air quality, the reduced heat stress, or the light itself. In the real world, it's almost impossible to isolate the lighting effect. And that leads to warranted farmer skepticism about the singular ROI of the lights themselves. They wonder, was it really the lights?
And this is where we need to look at the biological messiness that sophisticated lighting companies conveniently skip over in their sales pitches. Let's talk about Dr. Dong-Hyun Lim's 2021 research for a sec.
Oh, that study published in Animals, yeah. That was critical because it moved beyond just looking at herd averages and actually looked at the individual cow. Lim's team found massive individual variation in melatonin response within the same herd. We're talking up to 10-fold differences in baseline melatonin levels and their response thresholds.
Tenfold. Think about what that means. You can have a cow that shows perfect melatonin suppression at a mere 50 lux. That's like a twilight setting, sitting right next to a cow that needs the full 200 lux, that office lighting level, to get the same hormonal response.
And if we connect this to the bigger picture, the source material specifically suggests that maybe only 30 to 40% of cows will respond strongly to photoperiod manipulation. The rest of the herd might see a moderate or even a low response.
Okay, so this raises a really important question then. If the biology is that messy and the response is so varied, why spend a fortune on a complex system trying to hit some perfect uniform target intensity across the whole barn?
Wait, I have to push back on that a little. Isn't that kind of defeatist? If technology could maybe identify the 40% of cows that respond best, or if we could use variable lighting to boost those slower responders, wouldn't that justify the complexity and the expense? Isn't that the whole promise of precision dairy?
Well, that is the promise, absolutely. But here's the problem with the implementation we see right now. The expensive systems often promise automated spectral tuning or integration with environmental monitoring. They look fantastic on the sales sheet, very high-tech. But if the underlying biological variation is so darn high, trying to precisely tune the light intensity or the wavelength for some theoretical perfect outcome is probably chasing diminishing returns. You're basically trying to hit a moving target with a complex missile when a simple hammer might work just as well for 80% of the job,
So the farmer's choice becomes: spend maybe $5,000 on a simple, robust system that reliably delivers the proven 16 hours of 150 lux, a known baseline for good suppression across most cows. Or spend $15,000, maybe more, on a system designed to achieve perfect uniformity across the barn, knowing full well that maybe 2/3 of the herd won't respond uniformly anyway because of their own biology.
That's the calculation. Stick to the proven basics. Adequate light, 16 to 18 hours. Simple systems are cheaper, they're generally more durable in harsh barn environments, and given the biological variation, they are likely just as effective for the vast majority of operations.
Okay, let's pivot to the economics, because ultimately capital outlay versus projected return is what drives adoption on farms. We established the rough ROI math earlier. A 100-cow herd, potentially generating $34,000 in additional annual revenue from that 8% bump, seems clear.
Now, compare that potential revenue to the cost of a simple, durable LED installation. If you're spending between, say, $3,000 and $5,000 for a commercial-grade system, the kind you find in warehouses, nothing fancy or dairy-specific, that payback period is projected to be incredibly fast. We are talking maybe 2 to 6 months to recoup the initial investment purely from increased milk sales.
That ROI makes it seem like a complete no-brainer. So why are people hesitating? The answer often lies in the details and the hidden costs. Many older barns are just not structurally or, more importantly, electrically ready for modern loads.
That's the silent killer of so many capital projects on farms. State extension guides, especially those focusing on infrastructure upgrades in older facilities, highlight this constantly. Older barns often require substantial electrical work that has nothing directly to do with the light fixture itself. We're talking panel upgrades, new wiring to handle the circuits, or maybe running new grounding systems, especially when switching from old low-voltage fixtures to modern LEDs.
Depending on your existing infrastructure, that adds a hidden cost of anywhere from like $2,000 to maybe $8,000 to the total investment. It can easily double the project cost. That hidden electrical bill is the reason so many lighting projects die on the drawing board. It changes the conversation from a simple lighting upgrade to a full and expensive utility overhaul.
And suddenly, that quick 2-month payback period stretches out to a year, maybe more. That makes it a much more calculated risk, especially when you factor in high current interest rates and the volatility of milk prices.
Beyond just the installation cost, let's talk durability and maintenance in the barn environment.
Yeah, think about the environment these electronics have to live in. Constant dust, high humidity, methane, ammonia. That environment is incredibly corrosive. We've seen it time and time again. Those delicate, fancy digital controllers designed to tune spectrum and integrate with smart barn systems. They often fail long before the actual LED chips do. I remember one farm visit, their state-of-the-art controller. It looked like it belonged on a spaceship. It just completely corroded after only 6 months. They ended up having to bypass the whole thing and just install a rugged, simple mechanical timer. You could probably buy at any hardware store. Durability really matters more than bells and whistles in a dairy barn.
That speaks volumes about prioritizing resilience over features.
Yeah.
But let's not overlook one major, maybe unforeseen benefit that really changes the ROI calculation, especially regionally: heat reduction.
Oh, this is a massive factor that often gets overlooked but can sometimes override the main photoperiod effect. LEDs generate about 50% less heat than traditional metal halides or those older high-intensity discharge lamps.
50% less heat is huge. For farmers in the Southeast or Southwest, think Georgia, Florida, Southern California, where heat stress can absolutely wipe out production and compromise health for maybe 8 months a year. The reduced heat load from the LEDs might actually be the single most valuable feature of the upgrade. It's a dual benefit. You get the photoperiod increase and a crucial tool for heat stress mitigation.
Definitely. And remember the financial offsets, too. Before anyone writes that check for new lights, you absolutely must check with your local utility provider. Energy efficiency rebates are widely available, often covering 20 to 40% of the cost of switching to modern LED systems. That can significantly shorten the payback period again, especially since LEDs have a ridiculously long lifespan, like 50,000 plus hours, compared to the short life of old fixtures. Hashtag for regional considerations and case studies.
The lesson emerging here, I think, is that the photoperiod benefit is really not one size fits all. Regional variations fundamentally change the ROI equation and probably the decision on what kind of system to buy, if any.
Absolutely. The regions that see the highest, most consistent ROI are clearly the ones with long, dark confinement periods. Specifically, you look at the upper Midwest, Minnesota, Wisconsin, Michigan. When cows are inside from October right through April and natural daylight hours are super short, that extended photoperiod provides a monumental boost that simply doesn't exist to the same degree elsewhere.
Yeah, take northern Minnesota in December. They might only get, 8 or 9 hours of effective natural daylight. That forces the cow system into a constant short day cycle, which naturally suppresses production. Installing long-day lighting immediately reverses that natural biological constraint. It's a huge lever there.
Now, compare that to somewhere like the California Central Valley, which has extensive open-sided or freestall facilities. For much of the year, natural light already provides adequate exposure. You're not starting from a baseline of 40 lux. You're starting from maybe 2,000 lux outside and easily 150 lux inside the shade on a bright day. The incremental gain from an artificial lighting upgrade is going to be much, much smaller.
And then you have grazing operations, say in parts of New York or Wisconsin, where cows are out on pasture during the peak production months like spring and summer. Those animals are outside getting plenty of natural light during the optimal 16-hour period anyway, so the indoor barn lighting upgrade provides minimal benefit during those key months. Their investment needs to be timed or maybe focused differently, perhaps just for the winter.
And circling back to that heat stress factor, the Southeast and Southwest are kind of unique cases. Down in Georgia or Florida, if the barn is consistently above 80 degrees Fahrenheit, the cow is stressed, and frankly, the lighting benefits are likely negated by that stress. Here, the primary driver for an LED upgrade might be purely heat mitigation and energy savings, not really photoperiod manipulation. The economic justification shifts completely from more milk to less stress and better energy efficiency.
Okay, so if you're listening to this and you're thinking, all right, maybe I do need to act. How do you do it intelligently without taking a huge risk? We'd advocate for the smart, low-risk approach. You test small first.
This is critical. First, you identify the darkest, maybe lowest performing section of your barn. Perhaps it's an old addition or a far end that never got proper maintenance. That's your testing group.
Then install simple, commercial-grade LED fixtures in just that area. Nothing proprietary, nothing fancy. Use a basic mechanical timer, keep the groups separate if you can, and then monitor that specific group of cows closely for 6 to 8 weeks. You need hard data from your own farm. Daily production changes, maybe changes in behavior, even feed intake metrics if you can track them for that group.
This provides you with farm-specific data. If you see clear, measurable, real-world improvements on your farm, not just projections from some consultant's glossy sales sheet, then, okay, maybe you expand gradually. But if you see no significant improvement after that trial period, you've spent maybe a few $100s on a test, and you've learned something invaluable, your limited capital should probably be spent on ventilation or feed management or something else instead. #5, future implications and technology hype.
Let's talk a little about the future and the hype surrounding this. When you look at the product landscape, every manufacturer seems to promise some revolutionary AI-optimized system. But what's the reality of the underlying technology?
Well, the reality is fundamentally standard LED chips are powering almost all these systems. Whether it's Samsung, Osram, or Cree, they are basically the same chips used in industrial warehouses. There is no magical dairy-specific LED chip that somehow justifies a huge price tag. It's commodity technology at the core.
The complexity, and therefore the cost, really comes from the sophisticated control systems they bundle with it. But we've already kind of established that for the core photoperiod effect, the melatonin suppression, the best control system is often just a basic, reliable mechanical timer set for that 16-hour on, 8-hour off cycle. Simple.
Now, we should acknowledge there are a few genuinely useful innovations that solve practical problems, like deep red lighting. That's a good example.
Yeah. That's the exception that proves the rule, maybe. Since cows apparently cannot see deep red wavelengths, specifically around 650 nanometers, you can introduce red lighting for night work without disrupting their crucial dark period.
This is actually huge for large operations or those in northern states during those long winter nights. Workers can check animals, handle emergencies like a calving, or even scrape alleys without turning on bright white lights and disrupting the cow's essential 8 hours of darkness. That is solving a real, practical operational conflict. That makes sense.
But beyond that, we pretty quickly enter the realm of solutions looking for problems, don't we? We hear about ongoing university research, which is fascinating stuff. Things like using circadian rhythms to predict health problems before clinical symptoms appear, or linking specific light exposure to immune function. That's valuable basic science.
But then that basic science somehow gets translated on the trade show floor into pitches for, like, AI optimization platforms that integrate light sensors with activity monitors, and I've actually heard this pitched, blockchain-verified lighting schedules.
Blockchain, come on. I'm not buying the blockchain lighting schedule. I just refuse.
Exactly. Cows don't need blockchain verification. They need light. The basic biological need is adequate light for a sufficient number of hours. That foundational requirement is where, 80% of the benefit lies. Chasing the final 5%, trying to perfectly tune the light for a herd with that tenfold melatonin variation we talked about, with complex, expensive software, it simply doesn't justify the investment risk for most operations. Keep it simple.
We need to challenge the popular industry narrative that the low adoption of lighting technology is somehow due to farmer resistance to change, or maybe a lack of forward thinking.
Yeah, that narrative is not only a bit condescending, it's often factually inaccurate. It's not resistance, it's justified caution regarding unnecessary risk. Dairy margins are tighter than they've been in decades for many. A farmer gets maybe 3 or 4 decades of active farming decision, big capital projects. Every technology bet risks one of those limited opportunities.
And if a farmer is highly leveraged, they simply can't afford to gamble on a complex system that might only deliver a marginally better result than a reliable, simple system costing 1/10 as much. They have to prioritize proven, simple durability. It's smart business.
And here's the critical point, I think, and the research definitely backs this up. Technology will never fix poor management. Ever. We know that stress hormones, whether from high somatic cell counts, unresolved lameness, or chronic heat stress, completely override any potential benefit you might get from photoperiod manipulation. The cow's body is already dealing with a major biological crisis.
Right. The lighting benefit is basically nullified by those larger systemic issues. You absolutely have to fix the management basics first. Lighting is a productivity enhancer. It's not some magic fix for underlying herd health or comfort problems.
The whole lighting story is really just one more reflection of the adoption pattern we see across almost all dairy technology, robotics, monitors, precision feeders, you name it. Adoption is usually driven by one of two things. Either a financial crisis that forces efficiency gains, or a generational change that brings a different tolerance for risk and capital investment. Lighting has just been kind of waiting in the queue because the return, though potentially massive, often requires addressing those hidden electrical costs first, which is a bigger project.
So perhaps the fact that most barns still run those museum-quality fixtures isn't really about being behind the times, but about experienced managers prioritizing capital protection and proven solutions.
Exactly. If simple LED bulbs and a basic timer can deliver similar results to systems costing 10 times more, which the biological messiness strongly suggests they often can, then the low adoption rate isn't a failure to innovate. It's simply good management protecting capital. That kind of farm wisdom, that practical caution, is priceless.
That is a strong final point. Knowing the difference between what actually works reliably and what just sounds fancy and expensive is really the core of good decision-making on the farm. #tag actionable insight segment. All right, let's bring it home. Farmer just finished morning milking, maybe they're driving to the feed store, or perhaps just checking in on the dry cow pen. What are the 3 key things they need to take away from this discussion? What are the immediate, medium, and long-term actions?
Okay, number 1, immediate action, something you can literally do this week. Measure your baseline light intensity.
You absolutely cannot just guess this. Purchase or borrow a simple, reliable light meter. They're pretty cheap, $60 to $100, easily accessible online or at electrical supply stores. Your goal is to measure light intensity right at cow eye level, so about 4 feet off the ground, in the darkest and the lightest areas of your barn during the daytime when the lights would normally be on. Get real numbers.
And use this simple decision framework. If you are consistently below 50 lux pretty much everywhere, you have a massive, proven, immediate opportunity for that potential 8% production boost. That's your green light. If you are consistently above 150 lux throughout your facility already, honestly, spend your limited capital elsewhere. You likely won't see a big return. Do not buy new lights just because.
Okay, number 2, medium-term strategy. Thinking over the next 3 to 6 months. Test small and focus on management prerequisites.
If you are one of those farms consistently below that 50 lux threshold, conduct a small monitored trial in the darkest section of the barn first. Don't redo the whole barn yet. Use simple, durable, commercial-grade LED fixtures and basic mechanical timers. Keep it cheap and robust for the test. Critically, though, before you even do that, ensure your core management, things like herd health, fresh cow protocols, nutrition, cow comfort, is absolutely dialed in. Remember, stress hormones will override the lighting benefits, so fix the foundation first. Don't put the cart before the horse.
Makes sense. And finally, number 3, long-term positioning. Looking out over the next 1 to 2 years. Factor lighting into all capital projects, especially electrical.
Right. If you are already planning a major renovation, building a new facility, or doing significant electrical upgrades anyway, that is the ideal time to incorporate proper photoperiod lighting, 16 to 18 hours at 100 to 200 lux. By bundling it with existing electrical work, you minimize the proportional impact of those potentially nasty hidden $2,000 to $8,000 electrical costs. It just becomes part of the bigger project. And definitely don't forget to call your local utility company about those energy efficiency rebates. Getting 20 to 40% off the top makes the math work almost every single time, significantly reducing that payback period.
Those are 3 clear, actionable steps that respect the farm's capital and risk tolerance, moving the conversation away from the fancy gimmicks and back to the basic science and practical application.
This has been another deep dive from the Bullvine podcast. What we hope you take away from this is the immense value of focusing on simple, measurable solutions over just the marketing hype. If this kind of impartial, data-driven analysis helps your operation make better decisions, head over to www.thebullvine.com for more articles that tell you what's really happening in dairy.
And seriously, subscribe wherever you get your podcasts. We're releasing episodes twice weekly now, and trust me, you don't want to miss what we've got coming next week. We're diving into the real cost-benefit analysis of activity monitors, especially for smaller dairy herds. That should be interesting. Until then, keep observing those cows and maybe go measure your light.